learning is the creation of machines which use techniques inspired by the human brain's ability to learn. Until recently, we simply didn't have enough data and processing power to train a machine to learn. Deep learning neural networks learn many levels of abstraction. They range from simple concepts to complex ones. This is what puts the deep in deep learning. Each layer categorizes some kind of information, refines it, and passes it along to the next. Deep learning lets a machine use this process to build a hierarchical representation. So, the first layer, for example, with a facial recognition system, might look for simple edges. The next might look for collections of edges that form simple shapes like rectangles or circles. The third might identify features like eyes and noses. After 5 or 6 layers, the neural network can put these features together. The result? A machine that can recognize certain objects or even concepts dependent on the training dataset. Humans learn numbers 0 to 9 in about 3 to 5 years with parents and teachers helping. Computers can learn numbers with a CPU, recognizing even handwritten numbers in a day. GPUs, on the other hand, do this in an hour. That's because GPUs perform many calculations at once, or in parallel. And once a system is trained with GPUs, scientists and researchers can put that learning to work.
We've had a lot of success in deep learning in industrial applications with supervised learning. So with supervised learning, we kind of guide the computer, take it by the hand and tell it, for this example you should do this, for this example you should do this, and it requires a lot of human labor. It works for many data sets that we're doing well on now for images and speech, and even some are natural language, but if we really aim for AI, we need to be able to let the computer learn more by itself. We can still give it these human labeled examples, but it should be able to use a lot more data. A 2-year-old child hasn't been supervised that much. He was able to learn just by observing and experimenting the world. So that's what we're trying to aim with unsupervised learning.
Deep learning has had countless applications, ranging from medical diagnosis, robotics, and automotive safety to speech and text recognition.
So I think that deep learning is going to be applied in a lot more applications over the next several years. One of the things that's really exciting about deep learning is that it's taking a lot of problems that used to be very specialized and sort of secrets of like an art, sort of things that people had a lot of domain knowledge on, and transferring that into an engineering problem so that people, even without a lot of domain expertise, are able to solve hard problems in many different domains. And because of this, I think deep learning is going to be applied very widely in a lot of surprising places. I think we're going to see deep learning applied to many different domains. I think a lot of domains are really important, especially domains involving text and speech, because that's kind of the primary modalities that humans use to interact with each other. And deep learning is going to give us the ability to understand that and to generate content.
We're just scratching the surface. That's why researchers at top universities worldwide and a host of startups are rushing to put deep learning to work.